Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. I'm making this recording for those who missed the class yesterday. I'm sorry there was something wrong with the Google Meet that such that I cannot. I'm not sure why I cannot record yesterday. So let's do this. Okay, so this is what we have discussed yesterday. So the purpose of this section is basically to introduce some formulas. So these formulas are basically shortcuts to save you time when you want to find the derivative. So we're going to start with a brief review of the concept of derivative. So this is how we define derivative. The derivative, so just, remember derivative is simply a derived term. A derived term of what? Term of a change analysis. So we analyze the change. Change of what? Change in one thing, which is x, our input or our control or our independent variable, okay, which will then lead to change in the output or f of x or the dependent variable. So this is the technical definition of derivative of f at x. So we use this notation, f prime of x is basically the change in the outputs. When we change inputs, so we first of all, we change inputs from x, we add some value h. So we start with the input of x, and then we add some inputs, some values h into x. So when we change the inputs, so surely the outputs will also change. So I always, to make it easy, you can use the example of your study hour and your result, your performance result, your grade. So if x is your if x is the input, so we have x, which is our input. So this you can think of x as your, for example, this can be study hours, or it can be number of workers. Okay. So surely this will then affect your f of x. So f of x is the output, okay, which is your either your grade or maybe your profit. Okay. So what happens when we change the input by a small amount? So surely our output will also change. So now that change, we will then have to divide by the amount of change that took place. And then derivative, the technical definition of derivative is that the change in output, when the change in input is very small, such that it approaches zero. So what if you change your study hours by 1 hour, or not 1 hour, let's say 1 minute or 1 second? So what will that then change? So that is the definition of derivative. Now derivative will only exist if the limit, this is what we term as the instantaneous change, where if h is too small, then this is basically the instantaneous change. So if this limit exists, then this is how we define derivative. Okay, so these are the different notation. I'm just going to leave this to you. Different notation, how we write the derivative of f at x. The change in f, okay, basically the change in output at x when at x when x changed by a very small amount, which is almost near to zero. Okay, so first shortcut, the first formula would be the constant function rule, where if we have a function, okay, which consists of a constant. So what happened to this constant when x changes? When x changes, and this is a constant, so it will not change at all. C will remain as it is. Okay. Yesterday I gave the example, if you really like someone, so regardless whether that person give you flowers or presents, a big present, small present, whatsoever, if you really love someone, it will remain the same. It will not really affect. Okay, if you really love someone sincerely, you like someone sincerely, so surely whatever that person's behavior will not affect your feelings towards them. Okay, so no change at all. Okay, so this is the easiest one. So the derivative of any constant function is 0, because if it is constant, then regardless how much you change the input, the output will remain the same. Okay. Next is power rule. So if we have x to the power of k, where k is a real number, so this is a power function. This is a power function. Now take note that the exponent k does not have to be an integer. An integer. It can be any real number. Okay, any real number. So in any real number mean it can be irrational number. Okay, it can be a rational number in decimal or fractional form. Okay, for example, we'll see the example later. So this is how we find the derivative, the shortcut formula, how to find the derivative of a power function. Okay, of a power function. So if n is any real number, so if this is x to the power of n, where n is any real number, then the derivative of f at x is, so we take this n, okay, we bring it to the front of x, it become a coefficient, okay, we're going to multiply this number, but then the power have to be reduced by 1, okay, by 1, okay. So example, so we have f of x to the, equals x to the power of 6. So by applying this formula, so we can have f of x basically equals to, so we bring 6 to the front, and then we have x to the power of 6 minus 1. So this gives us 6x to the power of 5. Okay. Another example, differentiating power function. So we have a power function like this. So this is f of x equals 1 over x to the power of 5. So solution, so we need to rewrite the function as a power function. So how do we rewrite this as a power function? So we're going to basically, so f of x would be, so this is in the denominator. So we can actually make it easy if we convert this. So this would become x to the power of negative 5. Okay, f to the power of negative 5. So we can simply apply. So when we do this, so what is our f of x? By applying the power rule, so we bring negative 5 to the front. We have x to the power of negative 5 minus 1. So this will give us negative 5x to the power of negative 6. Okay. And of course, you can rewrite this. So this is not elegant. So this is the more elegant way of how to write. The more elegant way is to make sure anything, basically the power, should not be negative. Should not be negative. But in an exam, if you leave your answer like this is also acceptable. Okay, acceptable. Just that to some people, this may look a bit messy, so they want to write it in a more elegant way. It's up to you. Okay, it's up to you. Another example, so this looks a bit complicated, but we can always rewrite the function as a power function. Just like in life, sometimes problems may seem to be complicated, but once you look at the problem from a different point of view, from different perspective, you try to rewrite the problem, you try to have a different way of looking at the problem, then perhaps the problem it's not as complicated as it seems in the first place. So how do we rewrite this? This is basically x. So this is the fourth root of x to the power of 3. So this is basically x to the power of 3 over 4. Okay, so this is a real number, but it is not an integer. Okay, so like we have mentioned before, the power doesn't need to be an integer. It can be any real number, rational, irrational, fraction. Okay, so we can just apply the power rule. Okay, the power rule. So here, how do we find the f prime of x? So f prime of x equals, so this is to the power of 3 over 4. So we're going to bring 3 over 4 to the front, and then we have x, and then we have 3 to the power of 3 over 4 minus 1. What is 1? 1 is 4 over 4. We have to subtract 1 because we were applying the power rule. So this becomes 3 over 4 x to the power of negative 1 over 4. Okay. Of course, you can rewrite this in a more elegant way, okay, which is this. Okay. But you can simply leave your answer like this. This is already acceptable in exam. Okay. Okay, I did not erase this from yesterday's discussion. So this is the third shortcut, constant multiple property. If we have a function which is a combination of a constant and a function, so how do we find the derivative? We simply differentiate, find the derivative of the function while the constant remain as it is. Okay, remain as it is. So this is the application of the example here. We have 12x to the power of 4. So 12 is simply a constant, so we just leave 12 as it is. But we bring 4 to the front here, x to the power of 4. So multiply with 4, 4 minus 1. So we have 12 multiplied by 4 give us 48x cubed. Okay. The fourth shortcut, if we have, if our function is a combination of two functions, either by adding or subtracting, okay, by plus or minus, then the derivative, if we want to find the derivative, we simply find the derivative of each of these functions separately. Okay, each of these functions separately. So we have in this example 3x to the power of 3 plus 11x to the power of 2. So we simply differentiate them separately. We find the derivative separately. So this becomes 3 multiplied by 3, 9x squared. 11 multiplied by 2 give us 22x. Okay, 22x. So if we have this, okay, this looks a bit complicated. Of course, there is a quotient rule later on, but actually there is a trick. I mean, how do you know how to apply tricks and stuff? This has to come from experience. You have to do more exercises. The more practices that you do, so inshallah the tricks or the hints should be revealed to you. Okay? This has to basically come through experience. So we have a rational function. So this is the numerator, denominator. Rather than applying the quotient formula, we can actually make the separate them. So how do we separate them? We can separate this into two. So 3 over x to the power of 6 minus x to the power of 3 over x to the power of 6. And we can simplify this. Each of these we can simplify them. So this, we bring this up. So the power becomes negative 6. And this one we can simplify. So 3 minus 6 give us negative 3. So this is our new f of x. So we can just differentiate them separately. So how do we differentiate them? So this one 3. So what is our f of x? So 3 multiplied by 6 is 18. And then we have x to the power of negative 7 minus. So minus, and this is minus. So this becomes plus 3x to the power of negative 4. So this should be the answer. Okay. This one. Of course, it doesn't look elegant, so you can simplify it. You can make it look, but this is already an acceptable answer. Okay. Application, I'm going to leave this to you. You can just do it on your own. Okay. Just take note of the interpretation. Okay. I mean, whenever you have examples of application, pay attention to the how it is being interpreted. Okay, how it is being interpreted. This is another example. If we want to find the equation of a tangent line, equation of tangent line. Okay. So let's say we have this, because derivative can also be interpreted as the slope of the tangent line. Okay. So how do we find the derivative? So f prime of x. So these are basically three terms. There are three terms here. So the derivative would be, so how do we find this? So this one becomes 9. Like this. Let's just try to do this together. 9x squared, right, minus 4x plus 0. Right? So this is our answer. Now, this is the derivative that we have found. Now, we need to find the equation of the tangent line. Okay, for x equals 1. Okay, for x equals 1. So what do we need to do? So first of all, when we substitute x equals 1, we get 6. Okay, we get 6. So now we need to find the tangent line at the point 1, 6. So this is the coordinate that we have. Okay, this is the coordinate that we have. Now the slope of the tangent line. So we don't have enough information yet. So we, in order to come up with equation in the point form, if you recall in chapter 1, we need to have at least two information. Either we need to have 2 points or we need to have 1 point and the slope. Okay, but the problem with this function is that the slope is not constant. Okay, it is quadratic. Okay, and it's quadratic. So the slope basically changes. Each point x would have different slope. I mean, if you put in different value of x, the slope, the derivative would have different values. Okay, so for x equals 1, so we know 1 point. We know the equation of the tangent line would pass this point 1 and 6, but we want to know what is the slope. So how do we find the slope? We simply substitute this here, okay, in order to get the slope. So when we plug in 1, so 9, 1 square is 1, 9 minus 4, it gives us 5. So 5 is the slope. Now that we have these two information, we can apply the point slope form. The point slope formula, so we simply put 6 here, and then we put 1 here, and 5 is our slope, m. Okay, so put everything there. So it simplifies to y equals 5x plus 1. So this is our equation of the tangent line. Okay. So how do we find the values of x where the tangent line is horizontal? So what is a horizontal tangent line? This is a horizontal line. So if we have our curve, something like that, so a horizontal tangent line would be a horizontal line. Okay, maybe here like this and like this. So what is the slope of a horizontal tangent line? So now we know the slope is 0. Okay, so we know here one information that we have is that the slope is 0. Okay, and we know this. Okay, we have this information. This is the slope, right? No, the slope of the tangent line. So a line is horizontal when the slope is 0. So how do we find the value of x? How do we find where does the tangent line is horizontal? We replace this value with 0. We make these two equal to 0 because the slope, this is the slope, okay, of a horizontal tangent line is 0. So we make it equal to 0, and then you solve for x. Okay, so there are two values of x. Okay, it's a square root, so it has two roots at 0 and 4 over 9. Okay, so this is where the location of a horizontal tangent line. So that's basically the end, okay, of the first part of the lecture. And let me just stop here for the first file. Okay.